Today we're going to look at arithmetic sequences, and we're going to start this by looking at a definition of what a sequence is. So in mathematics, a sequence is a set of numbers that follow a particular order or pattern. That's what a sequence is. So an arithmetic sequence then is a collection of numbers that follow a special linear pattern where each of the terms has a fixed difference between them. So a collection of numbers that follow a special pattern where each of the terms has a fixed difference between them. So that sounds a bit wordy, but we're going to go through some examples and take a look at this. So in this example here, we have a collection or a set of numbers, and a set, remember, is defined by these brackets here. This defines that everything within here is a set. Now, this is the first term in our set, and you'll notice that the difference between each of these terms is a fixed number. So here, the difference between these two, to get from the first term to the second term, I have to add 2. To get from the second term to the third term, I have to add 2, and so on. You'll notice that the difference between each of these is 2. This is called the common difference. So the common difference between each term in this sequence is 2. Let's take a look at another example here. In this example, here's our first term is 100, but you'll notice that getting to the second term, there's a difference of 3, but I would have to subtract 3 from the first term to get to the second term. Similarly, to get from the second term to the third term, I would have to subtract 3. And you'll notice that this is the same for each of these terms. So therefore, in this arithmetic sequence, the common difference is -3 in this one. Now, you'll also notice for both of these sequences, there's these 3 dots at the end. This symbolizes that these two are infinite sequences. These are called infinite because they don't end. They keep going on forever. Now, there is something called a finite sequence. This next example here is a finite sequence because it has a last term. This term here, we call it our first term. Our first term in this sequence is 1. And this term here, this is called our last term. And in this case, it happens to be 29. Now, let's take a look at what the common difference is. You'll notice that I had to add 7 to go from the first term to the second term. Similarly, to go to the third term, I had to add 7. And to go to the fourth term, I have to add 7. So in this case, the common difference is 7. Now, before we look further at terminology with these, let's just take a look and see how we can find each of these subsequent terms. So in this case, our first term here, our first term, this is 1. To get to our second term, we had to take our first term and add 7 to it. So we're adding our common difference. Now to get to the third term, we took the second term and added 7 again. So our second term is 1 plus 7 plus 7. Now let's take a look at our fourth term. Again, we take our third term and add our common difference to it. So our third term is 1 plus 7 plus 7, and we're going to add another 7 onto here. So hopefully you're seeing a pattern here where this is our first term here, and we're adding the number one less than the number of the term it is. So for example, for the fifth term, we're taking our first term and we're adding 4 sevens. So one less than the number that the term is. We're adding 4 sevens. So one more common difference every time we go through it. So here, this pattern then, we could say this is our first term and we're adding 4 times our common difference. 4 is 1 less than the term that it is. So 5 minus 1 times 7. So if we were to look for the nth term, for example, we would get 1 plus n minus 1 times the common difference. And this is particularly useful when we are trying to find specific term numbers for either finite or infinite sequences. So let's now take a look at some of the terminology. So for common difference, we typically use the letter D. So D stands for common difference. To find the first term, we use A sub 1. That denotes the first term. So it follows then that A sub n will be the nth term in our sequence. Now, looking back up here, we said this was the nth term, and there is a formula for that, and we call that T sub n. And T sub n is equal to our first term plus n minus 1 times our common difference. Okay, and that's the formula for finding the nth term. So let's take a look at some examples where we would use that. So in this first example here, find the common difference and the 20th term. So let's first of all look for the common difference. So between these two, the difference is 2. Similarly, between those two terms and those two terms. So I think we can safely say that D is equal to 2. Now A sub 1 is equal to 3. So we could find T sub 20, our 20th term, then is 3 plus 20 minus 1 times 2. So this gives us 3 plus 19 times 2, and that's 41. So our 20th term, we typically write that as A sub 20 is equal to 41. Let's look at another example here. In this next example, our first term is 11, so I'm going to write that here. A sub 1 is equal to 11. But notice to get to our second term, we had to subtract 3. Similarly, to go from our second term to third term, we're subtracting 3. So our value for D, our common difference, is negative 3. Now when we want to find our 20th term, we'll take our first term, and we're going to have 20 minus 1, n minus 1, times our value for D, negative 3. So that gives us 11 minus 3 times 19, and that gives us negative 46 for our 20th term. Okay, let's look at one more example here. And in this example, we are given our 6th term and our 18th term. But we're asked to find what the first term in this sequence is. So we can rewrite these terms in terms of t sub n. So we know that t sub 6 is equal to, in this case it's equal to 10, and that is equal to our first term plus n minus 1, so 6 minus 1, times our value for d, and we don't know that yet. So this becomes 10 is equal to a1 plus 5d. Let's do the same thing here for this term. So t sub 18, this we know is equal to 46, and this is a sub 1 plus, now here our n is 18, so 18 minus 1 times d. And this gives us 46 is equal to a sub 1 plus 17d. Now we can find a sub 1 and d, we know these are both the same for both these equations, using a process of elimination for finding a linear system. So let's go ahead and do that. I'm going to write these, lining them up. 46 is equal to a sub 1 plus 17d, and 10 is equal to a sub 1 plus 5d. And now let's go ahead and subtract those. So 36 is equal to a sub 1 minus a sub 1, that's 0. 17 minus 5 is 12d. So now we have 36 is equal to 12d. We can divide by 12 to give us d is equal to 36 over 12, or d. Now we can use that, we can put that into either of the equations up here to solve for a sub 1. So here 10 is equal to a sub 1 plus 5 times 3. So 10 is equal to a sub 1 plus 15. Subtract 15 from both sides to give us a sub 1 is equal to negative 5. And we can go ahead and double check that by putting that into this equation here to verify that d is 3. So if we did 46 is equal to negative 5 plus 17d, so add 5 to both sides. That gives us 51 is equal to 17d. Divide both by 17. And yes, indeed, d is equal to 3. And that's how you can find the first term and the common difference given two terms in an arithmetic sequence.